Okay, we're having a look at question 16 from the Maths Methods Tech Active paper for 2021. So we've got a diagram given to us. We've got DC is our vertical tower. We've got A and B are points in the same horizontal plane. And we've got some information about the angles that AD is to the horizontal and BD is to the horizontal. So we want to know about the distance between A and B. So obviously that is on our horizontal plane. We want to work out our sides. So we need to find out our side AC, and we're going to have to find out the side BC so that we can then try and work out the length of AB. So they're ones that we can start nice and easy because we have our two right angle triangles. So when we look at our triangle DCB, we have our 60 meters there, we've got our 35 degrees, and we want to know what our length BC is. Then we can look at our other triangle where we have our DC and A. We've got the 28 degrees there, and we have our height of 60 meters. So we can then use our trig ratios. So we have adjacent and opposite there. So tan theta is opposite over adjacent. So tan of 35 is going to equal our 60 over x. So then our x is going to be 60 over tan of 35. Now, just remembering that the rest of this paper, we've had our calculators in radians, so just don't forget to change your calculator back to degrees for this question. So when we're doing that, we're doing 60 divided by tan of 35, and we get 85.69, and that is meters. And then we're going to do our other one where we've got our tan, so we've got our y value there, opposite adjacent, so tan of theta is opposite over adjacent. Tan of 28 is going to equal our 60 over y. So our y is going to be 60 over tan 28. So we'll grab our calculator, 60 divided by tan 28. So we get our 112.84 meters for that one. Now the next bit is we need to find out what this angle is here. What's our angle C? Because we've got our A and B, and we can use our cosine rule to find out that side C there, but we need this angle. So what we do know about that scenario, so we've got our bearing from of C from A, we've got is 50 degrees. We then know about our bearing of C from B, and that's 300 degrees. So we can then find out some other pieces there. So if we change, and I'm just going to redraw the diagram just so it doesn't look like I'm drawing the tower in there. So what we've got on the ground is our triangle there. Oh, that's a yucky one. Let's try again. We've got our 50 degrees here. We've got our 300 degrees round to here. And we can put a north over here. So if we've got the 50 here, we can use our parallel line rules to say if I've got a 50, I know that this one here has to be 130 degrees. Then if I've got the 300 here, I know this piece here must be 60, which then means that must be 120 degrees. Now when I add the 120 and the 130, I get 250, which means this piece here must be 110 degrees. I'm now able to use that with my lengths that I have now worked out to do my c squared equals a squared plus b squared minus 2ab cos c, and solve for the c squared. So I'm putting in those values that I worked out over here, that 85.69, the 112.84, and I am taking away 2 times 85.59 times 112.84, and then I'm multiplying that by cos of 110. So I should get then, when I do the square root of that, 163.37 meters. So the biggest, I think probably the trickiest part of it was working out that angle there. The rest was fairly straightforward trigonometry.